Okay, so it's 11 o'clock, and I think that we can start. Um, so, hello, everybody, and welcome to today's webinar, Digital Forensics in the Era of Big Data. My name is Tomáš Kolárik, and I'm part of the team at the National Competence Centre for HPC in Slovakia, which is hosting this event together with our partners in Austria and the Czech Republic. We are really very happy to have you here today. It's my great pleasure to introduce our speaker, Dr. Mazhar Malik from UW Bristol, where he leads research in intelligent systems, cybersecurity, and digital forensics. Dr. Malik has many years of experience working in academia, and he'll show us today how high-performance computing can support digital forensics in large-scale environments, from cyber incident analysis to handling massive datasets. Feel free to post your questions in the chat at any time. After the talk, we'll open the floor for a Q&A session where you can ask your question directly to the speaker. Dr. Malik, the floor is yours.
Thank you so much, Thomas, for this introduction. Uh, as you know, my name is Mazhar Malik. I'm working for University of West of England. So my background is in industry and academia. So I am forensic investigator also, and I present as a I present digital evidences to courts here in UK also. So today I will talk about briefly how HPC can support digital forensic. So it's a quite challenging topic. So I think that someone have noise. Let me mute. Okay.
I'm
So it's quite interesting and challenging topic. So let me explore. It's not a lecture, honestly. It's just showing that how HPC can support digital forensic and what type of challenges we are facing. And I will explain about current some of the case studies or some of the tools which organizations country-wise government entities are using to explore the digital evidences. So, digital forensic in the digital in the era of digital forensic, basically leveraging high performance computing (HPC) for incident analysis has become essential in our today's complex cybersecurity landscape. And as you know, that digital forensic investigation is grows increasingly based on data driven. Traditional computing approaches are no more effective to keep this space going on. So this presentation will basically explore how HPC's technologies accelerate cyber incident investigation, enabling forensic analysts to process massive data sets more efficiently. And in this talk, I will come across with a couple of the case studies, couple of the case studies with couple of the tool which we are using in digital world. So if I talk about today's agenda, so we will start with introduction, then we will talk about digital forensic and big data, how HPC is in digital forensic, some real world use cases, tools, and then we will talk about challenge and challenges and considerations along with future trends, and then we will wind up of this session. So if we talk about briefly what is digital forensic, so basically perhaps everyone is aware, but just to recall, so digital forensic is basically a systematic investigation of cyber incidents through data analysis, which involve data collection, preserving, and analyzing digital as evidences to establish facts about security incident and supporting legal proceedings. So if you look at the real world, what is meant by this one? Let's suppose if there is any incident happened, let's suppose we found a laptop or we found a mobile or anything where we need to perform digital evidence. So what we will do, we will start collecting data. We will collect, we will preserve, we will analyze data, and based on that, we will establish facts about security incident, and then we will present those facts into legal proceedings. So cyber domain have all these things together, and in digital forensic we follow all these steps. And all of these are specialized fields. Let's suppose I will give you example. If I am a very good digital forensic examiner, but if I don't know how to present these evidences into code, it's mean it means that I will not able to convey my meaning. So for that reason, perhaps I need my expertise to be in how to present evidences into legal proceeding. So that is another particular domain where we get trained on how to present evidences. And then we talk about big data challenges. So if we look at current situation, the exponential growth of data from cloud environment, IoT devices, and enterprise networks has created unprecedented challenges of forensic analyst, which is time sensitive. Investigations required processing of terabytes or even the petabyte of potential evidences. So here it comes one of the main challenge which digital investigation is facing, and that is size of data. So when we talk about size of data, mean in hundred of GBs even, that take a very long time. So currently data size is in terabytes and petabytes. You can imagine that the traditional computing will not work in this case. So in this case, what is there? The HPCs. High performance computing enable large scale real time forensic analysis, and which can leveraging parallel processing capabilities. And what will happen due to this? This will decrease analysis time and will improve the detection of threats. Okay, so this is overall introduction about digital forensic, where is the big data and where is HPC. So if we talk about challenges now, what is happening in digital world? So I can say that challenges are into these three main categories. Uh, so if we talk about this one uh, from the top, need of faster analysis. This is very clear that when size of the data is in hundred of thousand of gigabytes, and then it's moving towards terabytes and petabytes, petabytes, it's not possible that we can rely on traditional computing, because forensic investigation itself take very long time, and if our processing speed is low, that will have very serious implications. Perhaps some of you are related to academia or even in industry. Perhaps you notice that even with the small, even with the small uh, amount of data, the data handling capacities or data handling capacities in forensic investigation is quite challenging. We need very high speed computational powers even to perform very basic investigation. So when data size is so big, when data is produced by different type of things which I mentioned previously, IoTs, cloud services, and many more things, then definitely we need to think about faster analysis, and that can happen only through effective use of HPC's powers. Then complex cyber threats. So if we talk about different type of threats, this is very important to understand before going further. So if we talk about different type of threats, here I mentioned three keywords. First one is APT, which is advanced persistent threat. Then zero-day exploits, and then we have sophisticated malwares. So if I talk about what are these things, APT is basically advanced persistent threat, and this is something very which is what is happening in this particular case. These are APTs are long-term targeted cyber attacks, which are conducted by highly skilled attackers. These often are related to national state or organized cyber criminals. So their goal is to steal sensitive data or sabotage the critical infrastructure, and they use sometime social engineering, malwares, and these type of things to remain undetected for months or even for years. So basically, the APTs are basically long-term attacks. Okay. Then I mentioned about zero day exploits. Basically, these are previously known as software vulnerabilities. So the danger of these is these are extremely hard to detect or defend against because no patch or fix uh, exit when the attack begin. So these are injected through software, and their common targets are basically our operating system, can be our browser, MS Offices, suites, and industrial control systems. And then I mentioned about malwares. Basically, malwares, they use stealth encryption and advanced techniques to detect and achieve their goals. And this can include different type of malwares. Some of them can be like can be used to avoid antiviruses. Some of them can operate in memory and they don't leave any traces in memory. And some of them can be related to can update or change its function during an attack. And there are different type of attacks they can cater. So this is something very important to keep in mind before going further. And if we look at from this one, you will realize that APT days exploit, they run for even for months and years. And when we have these type of things, and when these things are caught into digital forensic and what actually happened, then definitely you need more power to perform investigation. The sheer volume of data generated by modern systems has created a significant bottleneck in digital forensic investigations. What once took hours now generate terabytes of potential evidences, making traditional analysis method increasing impractical. An organization face mounting pressure to maintain robust forensic capabilities while handling increasingly sophisticated threats that can hide within massive datasets. Here I just mentioned one of the example. I will put into chat also. Fake Edit. Fake Edit is a website, and this website have around 1 million size of data. Okay, so they have around 1 million slides to perform forensic investigation. This is publicly data available. If we talk about this 1 million size of data, it will be in GBs. And even with this size of data, we start thinking about how HPCs can support. So terabytes or thousands of in hundreds of gigabytes is something very, very huge in digital forensic world. So you can imagine this one. So basically this data set is related to fake news detection, related to news through text, news through images. So both type of detection is there, uh, both type of data is there. And then running digital forensic on this one, using machine learning models on this one, definitely need very high computational power. So let me move further. How HPCs, how uh, high performance computing can support digital forensic. So in digital forensic, HPC enables rapid threat detection and response by distributing complex analysis tasks across multiple uh, compute nodes. This approach is particularly valuable for efficient large-scale file analysis, memory forensic, and pattern matching across massive datasets. So HPC is very, very useful. So applying the HPC's concepts into forensic world by distributing the complex tasks across multiple computers, that can help a lot. So, so HPCs in digital world. So there are different type of analysis. There are different type of analysis which we perform in digital forensic world. I will talk them here briefly, and then I will talk these analysis with respect to tools, which commonly used tools you can use if you are interested in forensic world, or if you are teaching forensic, or if you want to go into this domain, or even you are already expert in this domain and you want to explore more tools about that. So we have massive log file analysis. So what is massive log file analysis? HPC basically enables the rapid detection of anomalies across terabyte of event logs from multiple systems, which significantly reduce the time needed to identify security incident. So first thing here I will mention that one of the area in digital forensic is log analysis. So we have different type of tools which I will explain for all of these categories later on. And first type of category where which we do some sort of analysis is we perform analysis on log files. Then we have memory and disk analysis. And here we use parallel processing dramatically accelerate the analysis of memory RAM dumps and disk images, allows investigator to reduce deleted files and identify the malicious codes more efficiently. So second term is in digital forensic is we do memory analysis and we do disk analysis. So how we are doing now, just keep in mind that all these categories have their specialized tool which we are running, which we can run on traditional computers and HPCs. If the size is small, if you are doing for learning purpose, perhaps traditional computer can be useful. But if you are doing for research purpose, if you are practicing these things in real world application, if you are working for government agencies and all this thing, normally we use HPC's capabilities. Then network traffic analysis. HPC systems can process massive uh, PCAP files to identify suspicious connections, data filtrations attempts, and command and control traffic that might otherwise go undetected. Okay, so network traffic analysis is another something very uh, challenging field where we need very high speed computers to perform the traffic, to analyze traffic patterns and detecting if there is abnormal behavior in the traffic or not. And finally we have malware analysis. uh, so HPC powered sandboxing enables simultaneously analysis of thousands of malware samples, accelerating threat intelligence gathering and response capabilities. Okay, so these are some key areas. And if we talk about now real world use cases of HPCs in digital world, digital forensic is everywhere, and HPC, I will say also this is need of the time, and this is also everywhere in different sector of the life. So here I mentioned couple of sectors, starting with financial sector, then moving to healthcare, law enforcement, and military intelligence. All of these are using, they have effective use of HPCs in digital world. If we talk about banking sector, bank and financial institutions basically using AI driven HPC's analysis to detect fraud patterns across millions of transactions in real time. And this is basically potentially saving billions. And how this is happening? Because size of the data is humongous. We need to keep in mind that we need real-time computational power, and only HPC can help us, and HPCs are basically helping us to detect fraud patterns across real-time transaction. Then we talk about healthcare. Medical institutions employ HPC solutions to detect to protect sensitive patient data from increasingly sophisticated cybersecurity threats, ensuring they are compliant with their governing bodies, and they are maintaining the medical record properly. So healthcare have a big use of HPCs into digital forensic world. Then law enforcement and military intelligence, sometimes we can relate them together. Law enforcement, you know that police agencies, they leverage HPCs for large scale data correlation in cyber investigations, connecting evidences across multiple devices, accounts, and digital footprint to build comprehensive cases. And similarly, they use in military and intelligence uh, to analyze global threats, intelligence at large scales. So these are some use cases which I just put it here to see that how things are working. Now I will talk about Now I need to talk about digital forensic use cases which involve using HPCs in the UK and Europe. So I will try to mention some of the incidents which happened, and then in majority of the cases I will explain that how different countries, I will mention some of the examples of UK and some other European countries, that how they are using or which type of tools they are using. Keeping in mind these are very sensitive topics, sometimes the public data is not available. Okay, and so whatever publicly is available we can present. There are many things which are hidden in this particular domain, especially when we talk about national level. But whatever publicly in public domain information was present, I try to compile it and I just try to put it here. So here I will start with first UK case, which is called uh, Operation Ventic. It's called encrypted chat, or we say encrochat. So basically what happened in this particular, this is very interesting thing. It's publicly available. I put it a link here. I think after this session, I will share the slides also, and think you all will have the access to slides, and then you can explore the links. So basically, uh, in 2020, just 3-4 years back, all of these examples which I'm putting here, these are recent examples. Uh, Whatever was publicly available. So in 2020, the UK National Crime Agency collaborated with international partners to filtrate the encrypted communication platform, which is called EncroChat. This operation led to interception of over 70 million messages, resulting more than 3,000 arrests across the UK. And this HPC role was the National Crime Agency repurposed the cloud-based data analytics platform, leveraging HPC capabilities to process and analyze the vast volume of intercepted data efficiently. This enabled rapid identification of threats and coordination of law enforcement actions. In April 22, French cybercrime investigators planted a software implant on a EncroChat server and gaining access to over 70 million encrypted messages exchanged by criminals involved in drug traffic, money laundering, and firearm offenses. And this was shared with the UK National Cyber Agency through Europol. So this is basically real incidents which happened. And then what happened is that to respond swiftly to cover 200 potential threats to life, NCA used cloud-based analytical platform which was built on Amazon Web Service. Everyone knows about perhaps AWS, to process and analyze the flood of unstructured data. So keep in mind this data was encrypted. So you can imagine that firstly encryption to decryption and then understanding the pattern, it was a huge amount of work. And then machine learning algorithms, different type of image processing, text extraction tools was used. And uh, within 2 weeks, National Cybercrime Unit scaled its platform from 10 to 300 users, automating the trigger of critical information. And the analysis result was compiled into intelligence package and shared in real time with multiple UK law enforcement agencies such as police, Scotland, HMRC, which is related to tax and revenue, and metropolitan police. And basically, based on that, what happened? Uh, as a result of this particular operation, over 300 arrests was made, and authorities seized 6.5 tons of cocaine, 3 tons of heroin, 173 firearms, and 80 millions in cash. Okay, and this all happened because HPC was there. The processing was so efficient as compared to traditional system, and they was able to conclude everything within 2 weeks. Okay, so this is a real case study with the reference, and this is publicly available. Another thing is, I will say that uh, it's some sort of tools which countries are using. So nukes in the cybercrime investigation. So I will explain this one now. So this particular tool uh, is related to cyber forensic investigation and used by different authorities. It's not only in UK. Interpol, Europol, FBI's, all these mainly are using this one. And the reason to use this is basically uh, the reason to use this is one of the tool uh, which is very powerful. It was There are multiple tools available, but this is one of the famous tool which government authorities are using. There are other tools also, but a National Cybercrime Unit particularly tested this one on, and then they tested on multiple data sets, and then they picked this one. Reason was speed in processing of a huge set of data, ability to search across all these media types, and scalability for concurrent multiple device processing. And basically, what this tool is offering, faster investigation. First thing is faster investigation. Okay, so it can detect metadata very easily. It can process diverse type of evidences. If you look at currently the type of data which we are producing different type of data. Everyone is carrying mobile phones. Mobile phones can have Android, can have, let's suppose, uh, OS operating system, iOS operating system for iPhone. Then we talk about IoTs. IoTs are producing another set of data. We have computers, we have different type of operating system, we have cloud storages. So this tool basically is best suited to handle all these type of data effectively. And then this tool allows us to perform advanced data analysis and visualization. Okay, so it's detect communication network between suspects. It extract the visual entities like IP addresses, payments cards, email addresses, and faces. And then it's also help us to categorize things. Those who are related to machine learning, we use classifications. So group similar images together, and all these things are happening. It's also help accessible case management. Analysts and investigators can collaborate remotely via web interface, because this tool different type of agencies are using and can use. So it's have an option that we can collaborate remotely. Case data is easily tagged, reviewed, and shared in real time, and even non-technical user can identify patterns and connections. And it is scalable. Okay, so this is one of the famous tool which is in use. Okay, then another Europol decryption platform. Europol decryption platform is, I will say that this is the another real example of usage of HPCs to run for digital forensic. So basically, the primary goal of this Europol is to undermine the trust in lock-built ecosystem against criminal. And basically, what is happening is this platform is using GPUs to maximize the efficiency. Definitely mean HPCs are involved, and they focus on different type of, and they face different type of they focus on different type of things. Firstly, they focus on attribution, mean identifying real individual behind the online alias. uh, they also use for infrastructure tracking, and disabling digital infrastructures. That can be servers, that can be darknet, that can be darknet markets, and so on. And crypto tracing, following blockchain trend to trace ransom and money laundering. And challenges are operational security for by criminals, often low, but can still hinder operation if evidence are destroyed. And digital forensic lags. So, digital forensic lag means that one of the challenge in digital forensic here I will mention is uh, that commercial forensic tools are not in the pace with the secure digital design. I mean, there is always a race between that how the forensic tool can be more effective. Okay. So just to wind up this one, Eurochat basically operation was resulted 6,000 arrest and massive assets was seized. And this shows that how crime investigation today is much about technology competition as it is about strategic timing, human intelligence, and cross-border cooperation. So without these keywords like a technology competence, strategic planning, human intelligence, and cross-border cooperation, these things are not possible. And then I will go to next one. And this is tool normally used by German. BK de developed remote communication interception software. It is used in cyber crimes and terrorism cases, and they use the suggested use of HPCs for real-time analysis. Details remain classified by imply high performance computing. Here, with not much of the data is available in this particular domain, uh, but very small information about this tool is available using Wikipedia. Other than that, we can't see any much information about this particular tool, but Germany is using this one. And what I know is it was cost, they deployed this thing in 2018 with the cost of 5.8 million euros. So, so we can see that there are different type of tools in digital forensic world. Backup by HPC are used to handle large size of data. Now, I will talk about quickly the tools and framework for HPC enable forensic. So these are the commercial applications. Perhaps we don't have access to all of these or majority of these, which I talked previously. But it's good to build foundation that how it's good to know that how on national level things are happening. Okay, now I'm moving to a topic where I will explain all those four categories which was mentioned in this slide, starting with massive log analysis, memory, network, and malware analysis. Those who are interested to explore more things, or they are cyber specialist, or they are into machine learning and they want to play things into cyber domain, there are different type of tools available which we can use to perform digital forensic investigations and I try to categorize them here with respect to tools, and I will also try to highlight which of them are very famous or people are normally using for education purpose, for training purpose, and so on. So massive log file analysis. So on left side you can see couple of tool names with small description. So massive log file analysis. These tools help in parsing, searching, correlating, and visualizing massive logs. Here you can see some of the tools. ELK stack is a powerful suite for investigating and visualizing large log data set. So this is one of the what I will say is a famous tool. Then Splunk, enterprise log analysis and monitoring. This is also something people are using a lot in academia and commercial purpose. Greylog is a centralized log management and analysis tool. Apache, very famous Apache Hadoop. it's a distributed log processing in forensic investigation. So these are something like these three. A log to timeline. It's create timelines for various log activities. Whenever we need the logs one and we need the timeline for that one, this tool is very, very powerful. So normally these four tools are very, very powerful. Gray log is also used in many cases. So you can imagine that we have logs in terabytes or even in thousands of megabytes, in hundred of megabytes, and then running this tool. So we are depending on tool, and then to process all these things in a fast manner, we need very high performance computing. And digital forensic is only effective when the results are coming as soon as possible, in many cases in real time. Okay. Then we have memory and disk forensic. So in disk forensic, we use for volatile memory, RAM, and non-volatile mean the disk data acquisition and analysis. Volatile means the RAM and non-volatile is hard disk data. Okay. So here you can use different type of tools. Volatility framework. This is used for memory analysis. When we do forensic investigation doesn't mean that we take out the data from hard drives only. It's also need that what was in memory, what is in memory. And you can imagine that when we are talking about RAM, when we will switch off our computer, all the data which is available in RAM will no more will be available. And in forensic investigation, we focus also on RAM to extract the data from the RAM. And this is quite challenging. We use specialized tool to extract data from there. Then Recall is a Google-based backed alternative to volatility of RAM for analysis. This is also gaining popularity, but these first two tools, you can use either of these. Those are very strong tools. Okay. Uh, Volatility framework is freely available. It's free to use. Recall, I think it's not free. It's a paid one. Then we have autopsy. Many of you perhaps heard the name of autopsy. It's a open source free tool. It's a free tool for analysis, good for study purpose. So it's a GUI based digital forensic platform for disk analysis. So what we do using, so first two was memory analysis, and then the next three are basically disk analysis. Okay. So disk analysis doesn't mean only the disk of one computer. This can be, there are I will explain them later on what other two these three are doing, but they are also expanded to cloud analysis. Let's suppose you can scan all the cloud services from Gmail, from Microsoft, or whatever type of cloud analysis you want to do, you can do using these ones. Autopsy is open source. X-Ways Forensic and Magnet XEM is a commercial tool for disk and memory artifact extraction. Okay, so even this Magnet XEM is used for both purpose. It's a commercial tool. If you search on Google Magnet XEM, you will find on their website that they give a 30 days trial version. This tool is very famous now. Normally, police is using a lot now, um, and even in universities, uh, they are using X-Ways. Mainly, they are using Magnet. And another tool is, I will put here name In-Case. In-Case is another very powerful tool, uh, but now the Magnet offer more options, so people are now, what I noticed is switching from In-Case to Magnet. So these three are powerful tool. Autopsy, as I said, Autopsy is a free tool. You can download and you can use it. Okay, then we have network analysis. Perhaps many of you heard about Wireshark, and Wireshark is a tool which help us to deepen packet inspection tool for network traffic. Then we have TCP dumps. TCP dumps is also very famous. It's used to capture packets, and it's a command line tool. We have network miner, which sniffs the packet for forensic investigation. Okay, this is also a famous tool. ProOZEEK is a network monitoring and traffic log framework. Okay, and then Net Witness Investigator is enterprise tool for traffic forensic analysis. See, when we run all these tools, let's suppose Wireshark, perhaps for practice, we can install and we can put on our own computer to understand which type of traffic is coming, and we can understand the traffic pattern, and we can inspect which type of data is coming. But when we talk about large scales organizations which are producing a large scale of data, then this Wireshark will not be implemented on standalone PC. Then we need capabilities of uh, GPUs. We need HPCs there because massive amount of data is coming on real time. Then our tool should have capacity to process that data, to handle that data properly, and then to perform the analysis. Okay. Malware analysis. Malware analysis have different tools now, and these tools are used for analyzing, reversing, and sandboxing malwares. And Cuckoo Sandbox is very famous for automated malware analysis, and there are some other tools, Ramnox, which is a Linux distribution with reverse engineering and malware analysis tool. We have IDA, hybrid analysis is another famous thing for online sandbox analysis for malware, and so on. So here I try to put some of the tools uh, uh, of different categories which we can use. If we talk about now challenges just and considerations, the first challenge is scalability and infrastructure cost. So there is a need of significant hardware investment and specialized software licensing cost and ongoing maintenance expenses. So normally these forensic tools which we use for commercial purpose, they are not free. In many cases, sometime in the past, the, for the educational purposes, they was giving free for limited time, but now since what I can say, since COVID and even yeah, these are all paid tools only for trial variant. They give us for trial 1 month or 1 week like that, and that's it. So there are a lot of costs involved. That's why sometimes it's difficult for organizations to scale these things. Data privacy and legal concerns, compliance with regulations like GDPR, uh, chain of custody maintenance, another challenge. Cross jurisdictional data handling, when people are involved from the different countries, keeping in mind GDPR, how data will be handled, and all these things are there. Skill gap and resource availability. This is something to motivate those who are thinking to start a new career, or they are thinking to upskill themselves. They are related to somewhere into machine learning, cyber security, or and they want to gain expertise into this particular area of digital forensic. I will say that there is a shortage of trained HPC forensic experts. Okay, and I think this will be situation across the UK and across the world. Same with the Europe. If you look at current situation, the only vacancies in UK market which are currently available are related to forensic experts. Okay, if I talk about generally in computing science, and if we talk about the majority of vacancies in this particular domain, you will see that they will talk about digital forensic, they will talk about cyber security, and then in cyber security, particularly forensic experts. Uh, because they are not isolated with AI discipline. Okay, so AI discipline, high performance computing, and forensic skills, all these things, if you mix together in your profile, that is something to something which can be a unique skill you will be carrying. Steep learning curve for new technologies, another thing. This is another challenge. Technologies are changing, things are changing a lot, and how to make sure that we upgrade ourselves. Okay, so perhaps if you are using a Topsy, which is open source tool, you will be interested to use what is actually happening in market, and perhaps you will be thinking about bringing in case X-rays or magnet. So different type of tools are there, but there is a big learning curve which is depending upon scalability and infrastructure of cost. And finally, definitely we need continuous improvements. Okay, second last slide, then I will stop. Future trends in HPC and digital forensic. So first is AI and quantum computing. Next generation forensic tools will leverage quantum computing and advanced AI to enable predictive threat analysis, identifying potential security incidents before they fully materialized. And then we need real-time forensic analytics. Mean emerging technologies will enable instant detection and analysis of breaches, dramatically reducing response time and limiting potential damage for security incident. And finally, cloud HPC integration. Decentralized forensic computing will become the norm with seamless integration between on-premises HPC resources and elastic cloud infrastructure, which will provide unprecedented scalable. Okay, so these technologies, we can expect that digital forensic to shift from primary reactive discipline to more proactive posture. Okay, and that can only happen when we will have continuous monitoring, we will have automatic response capabilities to handle the security threats in an effective way. So in digital forensic, basically one of the main challenges is how to become a proactive instead of reactive. Okay, we should proactively analyze our data, we should analyze our data in real time, and we should automate our response. So incident which is going to have a big impact, and that impact can minimize, and that will only happen when we will have real time forensic investigation, we will automate our process, and that will be the key thing. And for that, definitely you need very high power computing. Conclusion and key takeaways. HPC accelerate investigation. High performance computing dramatically reduce the analysis time for large scale digital forensic investigations, which enable rapid response to security incidents and minimize potential damage. Challenges for big data. Essential for big data challenges as digital evidence volume continue to grow exponentially. HPC provide the only viable solution for comprehensive analysis within reasonable time frame, making it an essential capability of modern cyber security teams. Future enhancement through AI and cloud, the integration of cloud and AI uh, through HPC resources will further enhance forensic capabilities, enabling more sophisticated analysis and making advanced forensic more accessible to organizations of all size. That's all. And here I put it some of the references. Basically, these references are coming from the discussion where I was talking about some of the cases. So these are references where this information is publicly available. So thank you so much. That's all from me. And now I'm happy to take any questions.
Okay, so wow, that was super exciting talk. Thank you very much. I'm opening now the Q&A session. So if anyone has a question for Dr. Malik, please go ahead.
Thomas, I will share slides with you. If someone needed, they can take it. Yeah.
Okay, that's great. Thank you very much. I think that attendees greatly appreciate that. So are there any questions for Dr. Malik? So if not, maybe you have to think about it more. Couple of minutes.
There are some
So
questions in the chat.
okay,
Yeah.
yeah. Thank you very much. Um,
Okay, so in chat, sorry, I forget to expand the slides. I think that is past now. Then for magnet axiom require a 64-bit of variant Windows. This is an okay. As I spoke previously, these all forensic tools, uh, the tools itself is very heavy thing. Okay, because they they have specialized capabilities, so you need a reasonable infrastructure to run these things. And normally, a very good latest laptop of computer you can use to practice these type of tools. You mentioned about magnet axiom and specification of that. Yeah, 8 GB of RAM. I mean, even it's recommended 8 GB of RAM, but if you have at least with 8 it will work, but not with the good processing or everything. So normally for education purposes, when we teach to our students, we use in industry for practice, we are using 32 GB or 64 GB of RAM. Okay. Okay, then yeah. Magnet axiom, see, it's depend upon scale, how we are using. If we talk about today's if we talk about in the world of academia, all universities or majority of universities they use HPCs in either way. They have their specialized labs where they are using high performance computing in some scale, and definitely when when students are doing research, let's suppose in our case, when we teach forensic on bachelor level or master level, uh, our universities labs, high speed labs are enough. Uh, and then we have a particular research labs in majority of universities, which we say HPC based labs basically. So then if someone is doing particular research of PhD on particular things, large processing of data, I gave one of the example, it was delete fake, something like that data set. I think that is in GB, and even in small GB of data that will be not processed by normal high-speed lab of the university. You need high-speed lab for that, and then they are using HPCs for that. But for learning curve, if we say that for learning curve, what we need to use is you can use any of that which can run your tool. Then someone mentioned that what about the learning path for a specialized HPC or cyber? There is no one right now. No, this is not the case. The learning path is there. The learning path is there. Uh, I try to categorize them into many categories, starting with the log analysis, the network analysis, and four type of categories was there. And I mentioned some of the tools. I try to give indication also which tool is free, which is not. So different type of free tools are available. Wireshark is free for network analysis. For for memory analysis, Virtuality is free. Then for disk analysis, Autopsy is free. So this can be a starting point to explore things. And then there was some other tools here and there which can be also free. So learning curve is there. And then all these organizations, whether Magnet, in case, or Xbase, they have their own specialized forensic certifications also. Some people want to pursue through certifications also, and they want to check their skills whether they gain sufficient knowledge and they can get stamp from that endorsement, that body, that oh, they are forensic expert on XYZ tool. So that can be another thing, but these are something you can keep in mind. Are there any initiative creating open source machine learning models for IDS? Okay, IDS, the initiative, what I can say is there are a lot of things in happening in this particular domain. There are different type of tools available. So there are some projects going on into IDS domain also as a open source. But what I say is due to nature of this domain, um, normally because normally they keep the tools for commercial purpose, and they keep the tool isolated from the normal use in many cases. I mean, if everything is available open source, then it's the open challenge to people to perform to dodge that systems also. So let's suppose I mentioned one of the system which was used by different national crime agencies. Perhaps that is not available for commercial use, which we use in our commercial life, only for specialized purpose. So that's the reason that everything not be something like a free, okay, or open source. May we have access to slide? Yes, definitely. I will share the slides. Someone said, what certification or school would you recommend for starting the digital forensic field? Uh, what I can say is, if you want to study, if you want to study uh, digital forensic, I always say that in majority of the universities, what we offer is we offer, let's suppose, BSc in cyber security. Okay. So what I want is, if you want to understand the complete thing about this particular domain, you should have knowledge of cyber security, and you should have also knowledge of digital forensic. If I say how they are different, this is same like virus and antivirus. When there is a virus, we create antivirus also. So in cyber security, basically we learn that how to secure things, how to secure your computer, how to secure a network, how to secure a cloud service, or so on. So we learn how to secure things. So this is called cyber security. But digital forensic is, even we secured everything, still attackers are very powerful. In one of my first slide, I talk about APT, zero net, and all these things. So attackers are very powerful. So still, with all this security, the incidents will happen, and then you should have knowledge how to perform forensic investigations on that. Okay, so any program which offers cyber security and digital forensic together, that can be very good learning curve. Firstly, you will learn how to secure things, and then you will learn that okay, when things was secured, uh, how how uh, how uh, how a security attack can happen, and how we will perform the investigation on that. Then someone said, based on your experience, what could be recommended as a most effective process or workflow for conducting a forensic investigation? See, when we perform forensic investigation, when we talk about forensic investigation, we look at scale of investigation. Okay, let's suppose if police seized a device, uh, they raid a house and they seized a device, and device was just a standalone computer and mobile phone, then your scale of investigation will be different. Okay, you will perform forensic investigation on mobile, you will perform forensic investigation on that computer, and you will take the images and you will start processing it on it. But when you look at the device, you realize that the person was using different type of cloud services to store the data. Perhaps was using OneDrive, can using Dropbox, using any other social medias and all this thing, and accounts was there. Then your target will be to extract the passwords from that device. And when you detected the passwords, and when you look at the size of data, you realize that the size of data is 1 GB. Then your plan will be different. And if you realized, oh, the guy was using a paid service by Google, and he is carrying 1000 GB of data or 100 GB of data, then this will give you trigger that which type of resources you needed, because you need a timely investigation based on that. Okay, not to leave things just as it is and performing an investigation which will take let's suppose 2 months like that. Okay, so that's all. I okay. And last question is, do you foresee the development of field applied to critical infrastructure? Definitely, definitely. I can see that. Okay, there is a need. Perhaps if I pick your question properly, applied. Like we are focusing like one of the key research area today is in forensic world and cyber world is use of AI into these things. So if you look at use of AI now, currently it's applied to every field. In all different sectors, we are using applied applications of AI into different domains and definitely into critical infrastructures also. And this is happening up to some extent. The tools which we are using for analysis purpose, I mentioned some of them, Hoops and all these things, they bring these things, they embedded these things into this. I think that's all. Anyone have any other questions? And I will share the slides to Thomas, and then Thomas can share with everyone. Thomas, over to you.
Okay, thank you very much, Dr. Malik, again for your excellent and inspiring talk. And thank you, dear participant, for your attention and questions. We're happy you joined us today, and we look forward to seeing you again at our next event. Have a great rest of the day. Yeah, thank you.
Thank you so much, Thomas, Lukia. Thank you so much.